My name is Erik Wikstrom. I'm the training manager at RTI, and I'd like to thank AAPM for this opportunity to discuss the possible benefits of using Ocean as a way to improve workflow in X-ray QA. QA, or quality assurance, is a wide term, so I'd like to narrow it down a bit for this presentation. But generally, QA in diagnostic radiology aims at ensuring that equipment performs so that it can provide images of sufficient quality and so that an accurate diagnosis can be made, all the while minimizing radiation risk to patients and staff. An important part of that is the testing that is performed. In diagnostic radiography, the following are examples of such tests: KV accuracy, dose reproducibility test, which we'll look at a little bit later, dose mass linearity, congruence of the X-ray field and the collimator light field, and beam quality, or HVL. And it's in these kinds of areas where RTI and Ocean software operate, the measurement and analysis of test parameters. Now, what future do we see for X-ray QA? Well, as with most technology, equipment is getting more complex, but also more competent and reliable. This is one factor behind the development of new test procedures and protocols. From both regulatory bodies and internal demand, the need for documentation increases. And financial aspects affect the priority for QA work. Patients who generate revenue should be in the exam rooms as much as possible, not staff performing tests. So how could Ocean possibly improve QA workflow? Well, since we are in the field of tests and measurements, we'll start with looking at an example, dose reproducibility test. First, we'll look at a traditional method, and then we'll do the same procedure using Ocean and a template, and also adding the use of a built-in analysis. We'll then look at a little bit more complex templates and discuss possible effects before going deeper into Ocean and exploring the possibilities of building a library of templates, using that to build a database of measurements and how this can be shared within a group. But first, let's look at the dose reproducibility test. We've taken this example from FDA, so I'm sure you have seen it, most of you, and that you're familiar with it. It's quite a simple test that requires us to make a set of 10 exposures and from them determine the coefficient of variation for that set of 10. The coefficient of variation must be less than 0.05 or 5%. As said, we'll start with the traditional method using pen and paper to record the measurement from the sequence where we maintain constant set values for KV and MAS. We've got Ocean set up for KV, time, dose rate, HVL, and total filtration. And we're ready for the first exposure. There we go, 40.59 MR. You make a note of that. Second exposure coming. That's 38.86. Third exposure, 39.34. Here we go, next exposure, 38.4. Soon halfway. $37.98. $38.88. That's exposure number 6. Four more to go. 37.14. 38.88. 38.45. $39.79. And the last exposure, 39.8. Now that we have all the data, we need to compute coefficient of variation. And how was that? We need to have a look at the formula. And we've got it here in the resource manual. Looks a bit tricky to do by hand, so let's do it in Excel instead. So we'll enter the data line by line, and see there's just a simple Excel formula. And there we've got measurement number 10. This means that we've arrived at a coefficient of variation of 2.6%, or 0.026, which is well below the limit of 5%, and we're done with this particular test. We can now sign off that it complies with the regulatory requirements in this respect. With the Ocean software, can save this the measurement file and open it in another format. And this file will open in real-time display mode to reuse the data that we've just collected. And here we see the 10 exposures all collected at the same time. From here we can add an analysis and choose from the built-in analyses that are available, for instance reproducibility. We go to next and see what parameter is it. We want to check the dose, which is exposure, of course, exposure reproducibility, and we need to define the acceptance limits. In this case we don't want to investigate the deviation from mean, only the maximum coefficient of variation, which is at here default 10%. The limit we want is 5%, so we'll modify that and finish. This gives us an analysis based on the data that we've collected in this set, the ones we did before. And if we compare what we had from the manual testing, we here in the Ocean get 2.6%, and that's what we got from the manual mode as well. To make sure that we have the right data, we may want to investigate and see, is this really the case? So we can go and find the more information about reproducibility and the analysis, and we get information on how it works and also what calculation is used to find the coefficient of variation and standard deviation, for instance. And we can see that the calculations are using the same method. Now, to reuse this setup and this analysis for a new set, we can save this template as a real-time display template. Give it a name, save it under a real name, which is a timestamp. And there we go. The template, of course, when we save it, is free of any data. It cleans it out. So here we go. We've got an empty grid waiting for data, and all we need is to get the measurement set ready. We can add measurements at any pace as long as we have a ready and green field. The system is ready to accept more data. And as you can see, we get an analysis as soon as we have enough data for it to process. And when we're advancing, we get closer to 10. We've got 9 measurements, and here is the final one, the 10th. And here we go, 10 dose values. We've got in this set a coefficient of variation of 2.9%, which is still pretty good. And here also is a plot of the deviation from mean. So these may not be big changes in the workflow as such, but some may be quite important, and most importantly, they're gained with no extra effort. So, to understand how Ocean could have a bigger impact on the workflow, we should look at it from a slightly different angle. How can we better utilize a software which has built-in functions specifically for X-ray QA? Well, for one, it allows us to design more complicated templates. Here is an example of a template that combines MA accuracy tests, KB accuracy tests, and dose reproducibility tests, as well as an MA linearity test and an HVL test as well, all in one template. Using this method, a customer saves 10 to 15 minutes compared to the traditional method. A template also offers the possibility to present the user with support information, like what tools and probes that could be used, or photos or drawings or circuit diagrams showing the measurement setup and other relevant info to increase the chance that the user performs the measurements in the same way. If that is achieved, data will correlate and thus improve data quality. In Ocean, we can also customize a range of templates for separate tests, and with them build a library of customized templates that can be combined depending on requirement. By building a library of different tests, the tests can then be combined into a session that comprises different tests. We can use templates to build a measurement database of structured measurements by selecting a template and associating that with a site. Site in this case could be a hospital or a clinic or similar. Each site will then have a department. Each department will have a set of rooms, and in the rooms there is where we do the testing. The session we're about to do is we'll give that a name to be able to identify it in the future. That's the measurement session, and off we go. This is a standard session which consists of a number of different tests: reproducibility test, an HVL test, KVP accuracy test, mass linearity, and all of these tests are then gathering the information from the meter. There's also a questionnaire, which is like a checklist, answering questions that may be relevant during the inspection. Gathering information like this, we build a database. Here we're again into the RTI electronics clinic. This site is then in the database has information like address, contact person, email address, and so forth. Department as well has some information. The room also. Equipment is generator and tube. And for those we have type, of course, the manufacturer details, and serial number for traceability. This information is then included in the reported data. Here we go. Here's the data that we've completed. We've got everything collected. And once that is done, of course, we can provide a report of the data of the tests being performed. Here's the site information again, and one page with the data for the different tests in a big row. All parts of the database can be shared. If we go in and right-click on a site, we have something called export. When you're performing a radiography test and you need a second opinion or you need something to compare it to, we can look at the history function with which we can compare. And as we move along, you see that the history also moves along, so we can see what has actually gone on, what are the measured, what are the values we have, and does it look okay, does it look reasonable. For a broader view, we could utilize the trend function and see the trends regarding reproducibility of, what do we want to look at? Well, let's look at exposure, the dose reproducibility. Any filters to the database? No, we won't have any filters. We'll look at the whole database. We don't have all that much data in it right now, but this is what we get. So this is a plot of dose reproducibility, and we can see that, well, we've got one which is off here, 2%, still very well within the limit. But if we click, we can see what measurement, was that about. It's this one right here then. So it gives us the data, the measurement data, also gives us a waveform, a possibility to test that. Were any problems with it? Did we have, what did we have, inaccuracies, and data regarding the full measurement, so that we can drill down and have a better view and understanding of what happened. So, in summary, Ocean could improve workflow by reducing downtime, and by direct data import, it reduces the time for data collection. Templates can combine tests and thus reducing the number of exposures that you need. Built-in analyses, well, you report instantly. There's no need to go back to the office and do hands-on work to complete the reporting. Harmonizing procedures will also be possible. We'll be able to get hints into Ocean templates that guide the user to a proper procedure. The update and modification of templates is easily distributable, and the harmonized procedure in themselves is a key to getting data that correlates. It also can improve and simplify the monitoring of an installed database. The measurement data can be shared across a team, pooled and analyzed to get a broader picture of the installed base. It's easy to compare current measurements with previous to see if there's been any change. And a trending function can mine the database for relevant data. And finally, the most obvious effect is that it can allow users to apply their expertise in evaluating analyses and data instead of typing data and designing forms. And with that, I'd like to thank you for your attention.